Greetings of the day, dear students. In this video, we are going to discuss about the PN junction diode. We will discuss its principle of operation. We will discuss its circuit symbol, diode symbol, and also what is the condition for forward bias mode and the VI characteristics, and also what is the condition for reverse bias mode, and two types of breakdowns that commonly occurs. One is the avalanche breakdown and another one Ginner breakdown, right? We will discuss in this video all these topics. Now, dear students, if you observe, the diode is a unilateral device which permits the flow of current only in one direction, but it opposes the flow of current in opposite direction. It opposes the flow of current in opposite direction, and it's nothing but a two electrode device, and it is going to have, it is nothing but simply a PN junction, right, which consists of two terminals on the two sides of the PN junction, and the one terminal, right, the terminal is called anode, and another one is the cathode. Another one is the cathode. The terminal towards p side, p type region is referred to as anode. Now the terminal towards n type region is referred to as cathode, right? Whereas the arrowhead indicates the direction of conventional current when the diode is forward bias. When the diode is what? Forward bias. So here, now, when we can say the diode is under forward bias condition, of course, it is made up of a semiconducting material. Most of the times, it is of either silicon or germanium. Silicon or germanium are the semiconducting materials used in a diode. Now, if you observe, A indicates anode, K is a cathode. When we used to connect the positive terminal of the supply towards the anode and the negative terminal of the supply towards the cathode, right, to the cathode, then the diode is said to be in forward bias. Then the diode is said to be in forward bias, right? And during that time, what happens? This is positively connected. This positive terminal is connected to the p type region. P type is already positive. Positive get repelled, so these holes will be pushed towards the n region, right? Now the n type is connected to the negative terminal. In already in n type region there will be electrons. Negative get repelled, so these electrons will be pulled towards the hole side, p region. Now the moment you cross a barrier voltage, there will be a sudden increase in the current. That point is important. If you observe this graph, up to certain point, even though the diode is forward biased, even though the voltage is slowly increased, up to certain point there is no conduction. The moment you cross the barrier potential, if it is, for example, if it is silicon, the barrier potential will be 0.7 volt. If it is germanium, the barrier potential will be zero point 0.3 volts. In this VI characteristics, you can observe that the moment the forward bias voltage has crossed 0.7 volt, there is a sudden rise in the current. There leads, it leads to the conduction of the diode. Now, previously up to that point, how the diode is behaved, just behaves like open switch. The moment it has crossed, right, it behaves like a closed switch. Right? Now here, uh, at the same time, for reverse biased condition, you can observe the graph. Up to certain point it will bear, there won't be any conduction. If the potential crosses certain point, then all of a sudden two types of breakdowns can occur. There is a chance for two types of breakdowns can occur. One is the Ginner breakdown and another one is the avalanche breakdown. Right? So here, you can observe the current units are in terms of milliamps. Forward bias voltage in volts on x-axis we have taken. On the negative x-axis we have taken the reverse bias voltage. On negative y-axis we have taken the reverse current. The units are, if you observe, the reverse current units are in microamps, whereas the forward bias current is in milliamps, right? Now when we can say the diode is in reverse bias, for example, the anode if it is connected to the negative terminal of the supply and cathode is connected to the positive terminal of the supply, then the diode is said to be in reverse bias. Then the diode is said to be in reverse bias. Right? Observe here, this negative is already connected to the p-type region, which is already positive. So negative positive will get attracted. Now this negative n-type region is already negative, is connected to the positive terminal of the battery. Now these two get attracted. Now this gap will be more. The depletion region gap will be more, right? Now but still under reverse bias condition also, due to the movement of minority charge carriers, there will be some small amount of current flow. There will be some small amount of current flow, that is mainly due to the minority charge carriers, charge carriers, right? Now there occurs a breakdown when the reverse bias voltage is reached a certain point. The junction breakdown occurs and the reverse current increases abruptly. That is what we can observe in the graph. In this VI characteristics, this reverse biased voltage slowly got increased up to here. He has beared that, and here also there is a one more breakdown. All of a sudden there is a rise in the current. Here also all of a sudden there is a rise in the current. These two things we can observe, right? Now, what about GNR breakdown, or what about avalanche breakdown? When we call it avalanche breakdown, when we call it as GNR breakdown, you have understood the critical value of the voltage at which breakdown of PN junction occurs is called a breakdown voltage. There are two types of breakdown. One is the avalanche breakdown and another one is the GNR breakdown. Now, due to the increase of the kinetic energy of the minority carriers with the increase in the reverse voltage, there will be the avalanche breakdown. It is mainly due to the kinetic energy attained or obtained by the minority charge carriers. For example, at sufficiently high reverse voltage of some 5 volts or more, the kinetic energy of the minority charge carriers will become very large, so that it will knock out the electrons from the covalent bond of the semiconducting material. Because of that, what happens is it leads to some collisions and it will liberate more electrons, in turn will get liberated, and more current will be flowing down. More electrons are liberated and more current will flow, and which leads to the breakdown of the crystal structure itself. This phenomenon is called avalanche breakdown. So in this entire discussion, the key point is it is mainly due to the kinetic energy of the minority charge carriers. Then what about GNR breakdown? It is mainly due to the electric field intensity which will be established across the depletion region. Already the diode is in reverse bias mode, right? Now because of the increased field intensity, electric field intensity across the junction under the reverse bias condition, there will be the expansion in the depletion region. There will be some expansion in the depletion region. Now with the increase in the more and more reverse biased voltage, it leads to the high more and more electric field across the junction. It leads to the more and more electric field across the junction. Now this electric field will break some of the covalent bonds of the atom, leading to the large number of free minority charge carriers, which will suddenly increase the reverse current. This effect is called GNR effect. This effect is called what? GNR effect. Now the breakdown at which the particular constant value of reverse biased voltage occurred, right? That is called breakdown voltage. The voltage value at which, at a particular value at which the breakdown occurred, that is to be called as breakdown voltage. That is to be called as breakdown voltage. Now if there is a diode junction that there is a breakdown that occurs below 5 volts, those are caused by the GNR effect. Now If the diode is experiencing a breakdown above 5 volts, those are caused by the avalanche effect. Those are caused by the avalanche effect. So which occurs first? There is a chance for which breakdown to occur first. Yeah, if it is less than below 5 volts itself, there occurred a breakdown, then it is due to the GNR breakdown. The potential has crossed above 5 volts, still breakdown have not occurred, but after crossing 5 volts there occurred a breakdown, then it is due to the avalanche breakdown. So this is what all about the diode, PN junction diode. It's a principle of operation and its BI characteristics: forward bias, reverse bias, right? Avalanche breakdown and Zener breakdown. Clear? Right. Okay, students. I request you to please share this application link with as many friends and as many students as possible, because with your help only it is possible to make this application reach the more number of students who really needs this application. It will be helpful for them to prepare for the basic electrical and electronics engineering subject. Utmost care has been taken to cover most of the universities and colleges syllabus. If any topic is missing, as per your notice, you can just simply WhatsApp the name of the topic and it will be added in few days. Right? Thank you.